So, dear students, today I am going to discuss one more problem on transient analysis. The main objective of this problem is to evaluate I di by dt d square I by dt square at t equal to 0 plus. 0 plus means soon after closing the switch or soon after operating the switch. Okay. Here, assume initial current of the inductor to be 0. So this is due to the switch was open for a long time. So if the switch was open for a long time, the current in the circuit is 0. Okay. Thus, the current in the inductor to be considered to be 0. Okay. Now we will analyze this circuit to evaluate I di by dt and d square I by dt square at t equal to 0 plus. Okay. So now we'll move towards the solution of this problem. Here the applied voltage is 100 volt, the value of resistance is 10 ohm and the value of inductance is 1 Henry. Okay. First we need to analyze the current in the circuit at 0 minus. That indicates, 0 minus indicates the analysis of circuit in history. That is, that shows past history of the circuit. Okay. Past history. We have to evaluate history of the circuit. History of the circuit. See, at t0 minus, switch K is open. Hence, current in the circuit is 0. Hence, current through inductor is given by I0 minus equal to 0. That will be equal to I0 plus. What's the reason? What is the reason for this one? Since current through inductor does not change instantaneously. Okay, whatever the current it was there before operating the switch, that will be the current in an inductor soon after closing the switch, soon after the instant closing the switch, that is at 0 plus. Okay. For t greater than, see what we have to do it now. For t greater than 0, K is closed. What is the respective circuit diagram? Here the switch is closed. And this is a complete closed loop circuit. Now we need to apply KVL for this loop. What's the KVL for this loop? Apply KVL for this circuit. That is I into R plus L di by dt equal to applied voltage, that is 100 volt. Here I am taking the notations. This is V, right? This is R. This is L. See, initially I am taking the notation of the various parameters in the circuit. Then I will be substituting the respective values. At t 0 plus, equation 2 becomes, put wherever the I is there, substitute in place of I0 plus. That indicates the current at I0 plus. Thus I0 plus into R plus L di 0 plus by dt, that is equal to V. Substitute the value of I0 plus. See, this value is evaluated over here. Substitute the same value in this equation. That is 0. So if you put this parameter equal to 0, this will be the answer for that. L di by di0 plus by dt equal to V, that is equal to 100 volt. Therefore, di0 plus by dt is equal to 100 amperes per second. This is di by dt. Thus, the unit of this current is 100 amperes per second. Okay. The next part is we need to evaluate the next current. The value of current is to evaluate d square I by dt square at 0 plus. Thus, we need to differentiate this equation, that is equation 2 with respect to a t. That yields us, if you differentiate this equation with respect to t, we will get di by dt into r plus L d square I by dt square equal to 0. Here it is. R di by dt plus L d square I by dt square equal to 0. Right. So we need to evaluate d square I by dt square at t 0 plus. Thus, the equation 5 becomes R di 0 plus divided by dt equal to L d square I 0 plus dt square equal to 0. Substitute the value of di by dt from the previous analysis. Thus, d square I by d square I 0 plus by dt square is equal to minus, so take this on right side, that is r by L di 0 plus by dt. Substitute the value of di by di 0 plus by dt, we will get 100 into 10, that will be d square I 0 plus by dt square is equal to 1000 amperes per second square. Thus, the complete solution of this problem. What is the problem? We need to evaluate I di by dt d square by dt square at 0 plus. Here is complete solution. Okay, at 0 plus, I 0 plus is 0. Here it is from analysis during past. Okay, that is reflected in history analysis. Okay, then di 0 plus by dt is equal to 100 ampere. That is from this relation. Substitute the value here. Substitute the value of I at 0 plus and simplify it. We will get di 0 plus by dt is equal to 100 ampere. That's the answer over here. Okay. Then d square I by dt square. So differentiate the equation number 2 with respect to t. We will get d square, that is r di by dt plus L d square I by dt square equal to V. That's a V is constant, DC voltage. Thus, differentiation of DC voltage is 0. Substitute the value of di 0 plus by dt from previous analysis. In this expression, we will get d square I 0 plus by dt square is equal to 1000 amperes per second. Okay, so this is the complete solution of the given example.